Hey, what's up, everyone? We're back here, and we're about to finish up this video series on Chapter 14, Water Pollution. What we're going to get through in this section here are about four different things. The first, guys, is going to be disease-causing agents. The next is going to be sediment pollution, thermal pollution, and lastly, inorganic chemicals. So let's just jump right into it, guys. So not a really fun thing to talk about, but we have to, and this is something that we're experiencing in the developing world, for sure, where wastewater goes untreated. People that have diseases don't have the proper waste disposal. They might not have plumbing, and excrement is making its way directly into waterways. And what we can see, guys, is an increase in bacteria that could cause diseases such as typhoid and cholera, dysentery. So these are all disease-causing agents that we can come across in our waterways. Okay, and it could be because of the fact that they don't have proper wastewater treatment going on. They could have medical waste that's just being dumped directly into rivers and streams, but those would be the sources of your disease-causing agents. Also, you can get plenty of bacteria coming from untreated runoff from agriculture. For instance, if there are feedlots or they have a lot of cattle, um, and that wastewater is just going directly into rivers and streams without being treated, that's going to be a spike of E. coli, which could be horrific and could cause death and disease on a large scale. You can actually test for that. And the most common way to test for it is by doing what's called a fecal coliform bacteria test. And it's kind of similar, like if you guys have ever been to like the doctor, and the doctor does like a throat swab, and they put it on a petri dish. They kind of swab it on that red petri dish, and then they incubate it for a while, and they see if something grows. And it's something similar to that, and it indicates E. coli present in waterways. And the Clean Water Act in the United States pretty much doesn't allow any E. coli to be in drinkable waterways in the United States. So that's something that's really monitored really well here, but as you can imagine, not monitored as well in developing nations. The next type, guys, of pollution that you can see is called sediment pollution. So let's get into talking about that. Give you an example. Clear cutting forest. Okay, you have all those trees holding down sediment, clear cut the forest, the roots are no longer holding onto the soil anymore, and then you start getting runoff. This can happen from deforestation, clear cutting. It can happen through open pit mining, where there used to be trees, the trees that are not there anymore. So here's your waterway that's clean. It's got the normal turbidity, which means the amount of sediment that's suspended within the water. So in this situation, what you're going to see here, right, is you're going to see light penetration. That's totally fine, normal. Transparency of the water allows that to happen. And when that happens, guys, you get plenty of photosynthetic activity happening. You get seagrasses that are growing from the bottom. Okay. There are also places for critters to live within rocks, or areas between rocks, I'm sorry. And this is where you have an area with low sediment. Okay. Now, if you throw a whole wrench into the works here, okay, and you have a situation where you're adding a tremendous amount of sediment into the waterway, well, let's guess what might happen here. Well, turbidity increases. Oh my goodness gracious. It was looking nice and clear. Now it's looking really, really drab and gross here. All right. So you can imagine what happens. First things first is you're not going to have as much sunlight being able to penetrate, right? So here's a situation where the sunlight is no longer penetrating to the bottom here. So then you can't have photosynthesis happening at the bottom. Not good. No photosynthesis. You're not having as much oxygen being added to the water. Even worse. On top of that, because the water is also now darker in color, The albedo has gone down. The reflectivity has gone down. It's absorbing more energy. You can imagine what might happen, guys. When the temperature goes up, what happens to the ability to hold on to dissolved oxygen? The answer is that goes down. So now we have less oxygen dissolved in the water. You don't have as many places for critters to live between rocks. And you're looking at a situation that's not good. Okay? So sediment pollution, increasing the temperature of the water, decreases dissolved oxygen. You're no longer having photosynthesis at the bottom because now the sunlight's not reaching the bottom, and you're going to have a lot of die-offs of little fishies. Okay, so that's pretty much your situation, all right, with an increased sediment load. All right, we're rocking and rolling here, folks. We're rocking and rolling. Oh, do we know anything about this location? Oh my goodness, we have control rods, we have radioactivity going on, we have water turning into steam. This is a nuclear power plant. It looks just like Indian Point where we were at. Well, why am I talking about this? Well, how about we mention what's going on right over here? Let's take a look, guys. What's going on right here? Bang. Waste heat. All right, the water inside, obviously, is going to be a lot hotter than the water going down the river. And that water can increase the temperature of the water right at that point source. And why is that a problem? It was the big deal. I mean, no big deal, right? All right, so let's talk about what could possibly go wrong here. Okay, so if we slip to the next slide here, let's take a look. Well, first things first, with thermal pollution, all right, you can get, well, reduced dissolved oxygen. We already talked about that already. We talked about 3 times. That's the 3rd time we're talking about that. All right, temperature goes up, the water can't hold on to the oxygen. It's like at the end of a stream. Eutrophic conditions at the end of a stream, oligotrophic at the headwaters. It's colder up there. All right, it can hold more oxygen. It's more aerated. Okay, in this situation, the point source pollution is increasing the temperature of the water. Okay, and take a look at the numbers. Look at the numbers right here. Okay, as you can see, as temperature goes up and up and up, all right, we have an inverse relationship here. Temperature goes up, dissolved oxygen capacity goes down. Okay, all right, next is it's going to increase the rate of bacterial decomposition. Just happens a lot faster when at higher temperatures, higher kinetic energy, a lot more going on. And then lastly, the fish living in that area, or whatever critters living in that area, or the shrimp, the fish, whatever it might be, when it's higher temperatures, their metabolism goes up, and it can cause their heart rate to go up, and they're burning more energy. Now they have to eat more, and what happens is their whole homeostasis gets thrown off. They live shorter lives, etc. Okay, and this is why river keepers go nuts about Indian Point, and it's because of the fact that they feel that thermal pollution is affecting the waterway. And depends on your take on it, though. And as we know, at Indian Point, they have systems of canals to decrease the temperature of the water before it gets out. But it depends on what side of the argument you're on. Okay. And lastly, guys, the last one that we're going to mention here to you, it will be, all right, inorganic chemicals. All right. This is why we don't eat paint chips, right, guys? Because they might contain lead. They no longer contain lead nowadays. But one type of inorganic chemical that you can come across is lead. All right, lead's a pretty heavy-duty neurotoxin, and it has gotten into waterways. And how does this actually happen? Well, here's the case study. We've heard about it before. Flint, Michigan. Okay, pipes that contain lead that are really, really old. They've corroded and eroded away, and the lead has gotten into the water and into the drinking water. It's a super sad situation going on there. Just horrible planning. A transition between using the different waterways from I believe it was from Detroit and then back to the Flint area, and just an utter disaster of epic proportions. We had lead in our gasoline, and that deposited into waterways, but because of the Clean Air Act, we're not seeing that anymore. We don't have leaded gasoline anymore, so we're not seeing that as much as a problem. The next guys would be the classic would be mercury. Coal fire burning is the main producer of mercury in the atmosphere. And what happens is that mercury gets up into the atmosphere. It then will then deposit into waterways or into the ground and into waterways. It'll then change through different critters like bacteria, etc., into like an organic form called methyl mercury. And then what happens with that is that it bioaccumulates in tissues, and then it can biomagnify through the food web. So bioaccumulates and then biomagnifies. So as you go through your trophic levels, the percentage of methylmercury would increase till you get to those secondary and tertiary consumers. And that's why people say don't eat as much tuna as you might want to eat, because you might potentially see a higher level of mercury in that. And who's most susceptible to mercury and lead? That's children. Children are most susceptible because they're developing, and when they're exposed to that, it can lead to developmental delays, and it's linked to many different developmental delays. So I won't get into that, but that's pretty much where that conversation leads to. Okay, so in this discussion, guys, we did discuss 4 different types very quickly of pollution. The first was disease-causing agents, developing countries mostly. Sediment pollution, this is runoff from agriculture, unsustainable agriculture, deforestation. We also talk about thermal pollution. That's from usually from industrial plants, a lot of the time through electrical generating plants, such as coal-fired plants and nuclear plants. And then we also discuss inorganic chemicals that can get into our waterways. Thank you for listening, guys, and take those notes. And this is Mr. Cloud signing out. We'll see you very soon, guys. Take care.